Let's take a look at covalent bonding, sharing of electrons. A covalent bond involves atoms sharing valence electrons to obtain a full outer shell, the octet rule. It is the electrostatic attraction between the nucleus and a pair of valence electrons. So here you can see the nucleus is positively charged and you have the negatively charged electrons. This molecule here is sharing this pair of electrons here, and the bond is formed between the positive nucleus and the negative electrons, and it holds this molecule together. Here's another example. We can see that we have CH4, which is methane, and you can see that the blue dots are electrons from the carbon atom and the red dots are the electrons from the hydrogen atom. So by sharing these electrons, hydrogen has 2 electrons in its outer shell, so it becomes stable, and carbon has 1, 2, 3, 4, 5, 6, 7, 8. So carbon has 8 electrons, it obeys the octet rule, and therefore it's stable. So we have single covalent bonds formed here, 4 covalent bonds. Final point. Covalent bonding occurs between non-metal elements, that is, elements on the right-hand side of the periodic table. Let's take a look at single, double and triple covalent bonds. Here we have 3 diatomic molecules. Diatomic means there are 2 atoms in a molecule. We have H2, which is hydrogen, O2, which is oxygen, and N2, which is nitrogen. So let's look at hydrogen first. We have 1 shared pair of electrons between the atoms. That's a single covalent bond, and it's shown by a single straight line. Next is oxygen. We have 2 shared pairs of electrons, and it's shown as a double line between the 2 atoms. And then for nitrogen, we have 3 shared pairs of electrons, and that's shown as 3 lines between the 2 atoms. So a single bond has 1 pair of electrons, 1 shared pair. A double bond has 2 shared pairs of electrons, and a triple bond has 3 shared pairs of electrons. Triple bonds are stronger and shorter than double and single bonds. Single bonds are the longest bonds and they're also the weakest. So let's look at a bit more detail of bond length and strength. Here we have 3 molecules. We have ethane, ethene and ethyne. As you can see, we have a single bond between the carbon atoms, 1 straight line. Here we have a double bond between the carbon atoms, and here we have a triple bond between the carbon atoms. Next is the length. As you can see, we go from single to double to triple. The bond length between the 2 carbon atoms goes from 153 to 134 to 120 picometers. So that shows that single bonds are the longest, double bonds are shorter, and triple bonds are the shortest. Next is the bond strength. This is the energy required to break that bond. So for a single bond, it's 347 kilojoules per mole. For a double bond, it's 614 kilojoules per mole, and for a triple bond, it's 839 kilojoules per mole. So that shows that a triple bond is strongest and the shortest, whereas a single bond is the longest and it's the weakest.